Hello everyone, welcome back. In this session, we are going to look at traveling salesman problem and solve it using least cost branch and bound method. So we have a graph which has 4 nodes and every edge has a weight. The same graph is represented in a two-dimensional grid. The diagonals are set to infinity so that we don't try to go to the same node from the same node. So we don't want to go from A to A or B to B or C to C or D to D. That's why they are set to infinity. So now branch and bound method is a method where we start from one node and tries to go to all other nodes. So, which means if the traveling salesman has to start from A and go to every other node once and come back to A, then he is going to start from A. Now from A, he can go to B, C, or D. And he is going to follow the path which will have least cost. Now, from that least cost node, he again follows other nodes and he keeps going and keeps following the optimal path. So that's what we are going to do in this solution for the least cost branch and bound. So the first step is reducing the rows. By reducing the rows, we mean we are going to look at every row and see which is the smallest value. So in this, the smallest is 4, 5, 4, and 5. And we are going to reduce the row with these values. So if we do that, what we are going to get is infinity. 12 minus 4 is 8, 0, 2. Similarly, this will be 3 and 0. And this will be 0, 4, and 11. This will be 6 minus 5 is 1, 0, 10, and infinity. What we did is we reduced every row with the value, with the minimum value in that row. And the total reduction in the row is 18. Now, so this is row reduction, which is 18. We are going to do the same for the column reduction. So we look at every column and check the minimum value in the column. 0, the minimum value in first column is 0, minimum value in second column is 0, 0, and 0. So we don't have to do anything because when we subtract 0 from every value in the column, the values remain same. So we say column reduction is 0 and our total reduction is 18 plus 0, which is 18. This means for this particular graph, from whichever path we go, the minimum cost from going from one node and coming back to the same node and traveling every node is going to be at least 18. Let me give you an example. A, B, C. So going from A to B is going to take 15. Now, if I reduce this by the minimum edge, which is 5, and make the graph like this, and I say that the total reduction was, I reduced 5 here and 5 here, which is 10. So if I start from 10 and go from A to B and B to C, then it will be 10 plus 0 plus 5, which is 15. So whatever I reduced, I started with that value. That's what we are going to do here. We reduced the graph and we started with the total reduced value. I'm going to delete this. Okay. So then this means if we start from A, the minimum is going to be 18, at least whichever path we are going to take. Now what we need to do is we need to find the cost from going from A to B, A to C and A to D, and whichever is going to be minimum, we are going to follow that path. Now to find that cost, what we are going to do is set ith row to infinity, set jth column to infinity, set to infinity. We are going to do these things, and this one is our current matrix. So now we have to calculate going from A to B, which is C, A, B. So what we are going to do is, as I said, set ith row, which is ath row, to infinity, and bth column to infinity, and b a to infinity. And then rest of the values are going to come from the current matrix, which is 3 and 0, 0, infinity 11, 1, 0, 10, infinity 1. This is already infinity, 1, 0, 10 and infinity. Now what we need to do is to calculate the path from A to B. This is going to be total reduction, CAB is going to be total reduction plus value at AB plus current reduction. Before finding this, what we are going to do is we are going to reduce the matrix again for all the rows and all the columns. So if we look at the rows, we need to see either everything has to be infinity or there should be at least a 0 in every row. This looks fine. This looks fine. It has 1, 0. It has all the indexes to infinity in this row. This row has at least a 0. This row does not have a 0. The minimum value is 1, and we are going to reduce it. So reducing will give us 0, 1 minus 1, infinity, 10 minus 1 is 9, and infinity. Now we are going to look at every column, and we see that this is 0, this has everything infinity, this has minimum 3, and this has 0. So we reduce the columns and we are going to get infinity, 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 and here 3 minus 3 is 0, 6, 0, 11, infinity. So our current reduction is going to be 1 plus 3, which is 4. So cost of AB is total reduction. Total reduction is 18 plus value at AB in the current matrix. So this is our current matrix and the value at AB is 8. So this is 8 plus current reduction, which is 4. So this comes out to be 30. This means going from A to B is 30. Similarly, we are going to calculate CAC. Remember, we are still working with our current matrix. So Ath row and Cth column and index at C and A. All these needs to be set to infinity, and then rest of the values are going to come from our current matrix. So the current matrix is 7, infinity 0, 0, 4, infinity 11, and 1, 0, infinity. Okay. Now again we are going to reduce every row and every column. So let's see. This is fine. This is fine. This has minimum 4. This has minimum 0. This looks good. So reducing, we get okay. And now looking at the columns, this has minimum 1. This looks okay. This looks okay. This looks okay. So reducing the column, we get 6 and 0. This will remain same, and rest of the columns are going to remain same. So then our current reduction comes out to be 4 plus 1, which is 5. And cost of going from A to C will be total reduction, which is 18, plus cost at A, C in the current matrix. Current matrix is this. AC is 0. 0 plus current reduction, which is 5. So this comes out to be 23. Doing the same way, we calculate AD, and this comes out to be 23. I'm not going to solve it fully, and let's say our final matrix was and our total cost came out to be 18 plus 2 plus 3, which is 20. So then this is 23 and this is 23. Let's say we follow AD because there is a tie between AC and AD. We are going to follow AD. This means from D we can either go to B or we can go to C. This means we need to find cost of DB and cost of DC. Now things are going to change because we followed AD. So our D matrix is going to be our current matrix and our total cost is going to be 23. So this will not be our current matrix anymore. Our current matrix is going to be this, because now we are starting from D and the matrix which was from A to D is going to be our current matrix and our total cost is going to be 23. So now going from D to B and D to C. So cost of D to B row D has to be infinity and column B has to be infinity and index BD has to be infinity. Now rest of the values are going to come from the current matrix. Now let's reduce it again. This looks okay, this looks okay, this looks okay, this looks okay. Looking at the columns, this is good, this is good, this is good, this is good. So our current reduction is 0 and cost of DB is total cost 23 plus cost at DB index in our current matrix. So DB is 0 plus our current reduction is 0. So this is 23. So going from DB is 23. Now let's calculate DC. So DC. Again, we need to make row D as infinity and column C infinity and index CD infinity, and rest of the values are going to come from our current matrix. Four infinity infinity 0 4. Let's see. So this row has minimum 4, this row has minimum 0, this is okay, this is okay. So reducing the row, zero, infinity, 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 0, 4. Now let's look at the columns. This looks good. The minimum is 4. This looks good. This looks good. So reducing the column, Okay, so then our current reduction is 4 plus 4 is equal to 8, and cost of DC is total reduction, which is 23, plus value at DC in current matrix. Current matrix is this, and value at DC is this, 10, plus current reduction is 8, which comes out to be 41. So DC is 41, and the minimum is this, so we are going to follow D. Now from B we can only go to C, and from C we can only go to A. So let's calculate B and C. Now things again change, because now our path current node is B, so then the matrix which we used for DB is going to be our current matrix, and our total cost is going to be this, which is the same as previous, but it might change. So you need to change your total cost with every change in your path. So DB, this means now this is your current matrix, and this is no more your current matrix, and this is your current total cost. So if we look at this matrix, and we need to find BC. So cost of BC, which will be Bth row is going to be infinity, and Cth column, and index at C, B is going to be infinity. Rest values are going to come from our current matrix, which will be, I think everything is going to be infinity except this. So if we see, we don't have to reduce again, and our cost will be total cost 23 plus cost as BC in our current matrix. Current matrix is this, BC is 0, plus current reduction is 0, which is 23. Now because we reached BC, so BC matrix is going to be our current matrix, and current total cost is 23. And now this is going to be our current matrix, total cost is 23. This is not our current matrix. So now from BC we are going to go back to A, which is CA. We don't have to do anything because this matrix is already reduced. So total cost is 23 plus value at CA is 0 plus current reduction is 0, which is 23. So our final cost going from A, touching every city and coming back to A, is going to be 23. And we followed this path. We followed A to D to B to C to A. Now if we look at the matrix, we followed A to D, D to B, B to C, and this. So totaling this, we get 6 plus 5 plus 8 plus 4, and which comes out to be 20. And this is your solution to traveling salesman using least cost Branchandbound. I hope you were able to understand all the solution which I gave. If you were not able to understand any part, I will recommend you go back and watch the video again. If you still have confusion, please write your question in the comments and I will try to answer. So this was a 4-node problem, but the solution could be generic. If you get a problem which has 5 nodes, let's say A, B, C, D, E, then the solution will remain same, although the solution is going to be a bit more lengthy, because let's say we want to go from A, then we can either go to B, C, D or E. So here we calculated A to B, A to C and A to D. Here you are going to calculate these. And let's say your A to D path was minimum. So then you will calculate B, C, E. Similarly, let's say your DC path was minimum. Then you are going to calculate B and E. And then again, let's say your minimum was CB. So then you will calculate E, and from E. So the steps are more, but you are going to do the same as I mentioned in the current lecture. So here I'm going to end this session, and we'll see you in some other problems related to Branchandbound and dynamic programming. Hope the session was informative. Thanks for watching, and bye for now.